Okay, 9.2, part 2. Definitions and formulas. So now we have a cylinder. It's a solid with two congruent circular bases that lie on parallel planes. We had that in our last group. You guys might remember it. It looks something like this. Can of soup. The surface area of a cylinder is 2 pi r squared plus 2 pi r h. This is the area of a circle. And this is the circumference of the circle, right? So it's the same formula as the last one, but with different letters. And the surface, or the lateral area of this cylinder is 2 pi RH, so just the second half. Okay, so here we want to find the lateral area and the surface area. So let's go with the surface area. We know the formula is 2 pi r squared plus 2 pi RH. So 2 pi r 3 inches squared plus 2 pi 3 inches times 5 inches. This gives me, this part here is 9 inches squared. 2 times 9 is 18. 18 pi inches squared plus 2 times 3 is 6. 6 times 5, that is 30 pi inches squared. We add those together and our surface area is 48 pi inches squared. The second part was just the lateral area. Remember, the lateral area is just this formula. So it's just this portion. We already worked that out, so we know that it's going to be 30. I see you can't see that. 30 pi inches squared. Our next one up, we're going to find that same surface area. I'm going to do it a little bit higher. So surface area, it's 2 pi r squared plus 2 pi RH. That gives me 2 pi, your diameter. Remember, we need radius, and radius is half a diameter. So 12 divided by 2, which is 6 feet. 6 feet squared plus 2 pi 6 feet times 10 feet. So 6 feet, or 6 squared, is going to give me 36. 36 times 2 is 72 pi feet squared. All I'm doing is multiplying those coefficients. And then on this side, I have 2 times 6, which is 12, times 10 is 120 pi feet squared. You're going to add those together, and that gives us 192. What blocks that off? And then I can go here, 192 pi feet squared. And then again, to find that lateral area, that's the second half of the formula, this portion. And we know what that is, 120. So it's 120 pi feet squared. Okay, one more slide. Okay, so this page is called matching nets. So we call them nets when you take a shape and you take it from a 3D shape to a 2D shape, or vice versa. If you take a 2D shape and you're able to turn it into a 3D shape. And so we're going to match. Well, if the first one up is a cylinder, you see it has a circular base. So if you go over to the other side, there's only 2 that have circular bases. Well, you see one has more of a point, and the other one has a box. So we know that these 2 are going to match. But this one, because it has that point on it, we know it's going to match with this cylindrical cone. Our next one up is here. You see you have a cube. That means all the sides are the same. The only ones that could potentially be that are the second and the fourth one. And we see the second one has 3 sides. They're just a little bit bigger, 4 sides. So we know that the cube has to go with this one where they're all the same size. Up here we have a triangular prism. Bases are triangles, sides are rectangles. So then we have sides as triangles and our bases as triangles, sides as rectangles is that top one. And then we have two others left. You see you have a triangular pyramid, triangle base, triangle sides. And the last one is a rectangular prism, rectangle bases, and then rectangular sides. So make sure that you can identify some of those. If this was still in class, we would be building these as a project and going through it. But since we're not, we're going to make with what we'd have to do and then try to identify them from here.